My name is Forrest Benson. My company is Redstone Incorporated out of Colorado Springs, Colorado. We mainly specialize in indoor and outdoor cannabis irrigation, both design and construction. So here we are actually in California, Calveras County. This is the Naughty Squirrel Farm. Been working with these guys a couple years now. I did their other location in Lake County. This is their new location, which is quite a bit larger in size. We have here just over about 3.5 acres of canopy spread over about 10 acres of cultivation area. This is the first of 3 phases. The farm will continue to build out. So a lot of the things that we worked at as far as the design and installation is how it's going to phase out and what we could do this year to get ready for next year.
That sounds great. Now you have a 100,000 gallon water tank behind you. Where does that fit into this whole picture?
Sure. So we're looking at a battery or a volume of water that we try to collect over a period of time and send it out to the field in a timely manner. So I refer to this, or it's called the irrigation window. So that's the overall amount of time that we have to water everything on the farm at peak season. Peak season being, the hottest day, July, August, when the ET is out the roof and the plants are drinking a lot of water. So I look at a number of variables and really plan for peak season. So here we have I believe this is just under 100,000 gallon water tank. And at peak season, we'll be using pretty much all of it. So as mentioned in July, August. Then next to the tank, we have another pad prepared for next year. So it's all ready to go with another tank. And then down from the tank, we have our pumping station, which also we've planned for expansion. We're going to be adding more pumps for every phase.
All right, let's go take a look
Sure.
at the pump. And then what is ET?
Evapotranspiration.
Say that again?
Evapotranspiration.
Evapotranspiration, and what does that mean to a person that doesn't know anything about water?
So the plant uses water to cool itself down through ET as well as usage. So that's just looking at a number of factors being temperature, humidity, all factor into ET and how much the plant is going to uptake as far as water.
Okay. All right, so let's take a look at this magnificent pump.
So this is a Watertronics pump. This was custom built and designed specifically for this farm and application. So the Watertronics pump, this is cool. It's kind of like a barbecue. We have all the components built in here. The centrifugal pump. We have the VFD driver, which controls the speed of the motor, also watches pressure through various transducers. So it's always reading and adjusting flow and pressure according to the settings. And then also we have another box, which is kind of a smart system to also monitor flow and control the filter that's on the backside here.
Okay.
This is the primary filter out of the tank. We have lots of filtration built into the system. This would be the first line of defense. So we have a self-flushing screen filter, and this thing pretty well just takes care of itself. Might need some seasonal maintenance, but yeah, this will be our first line of filtration, and then the filter goes in and back, or out and then back into the enclosure, and then we drop down into the field right here. Okay. Once we drop into the field, we have a series of valves in the ground, and what we call a home run. So we pick up the water from this valve will go straight to the field. We don't really have any shared main lines in this system. So every line will feed out to a different field.
water get from the well to the tank?
So there's a series of piping that brings water all together, and then we have the inlet for the tank. And then that was done by Eugene. Did you speak with you or interview Eugene in the process? He was the well guy.
I did not.
Okay. So he put together a series of, or he connected all the wells and then has controls to where with float switches. So as water drops below a certain level, it's going to turn on certain pumps to stay full.
Okay, so if I'm getting this right, the water's coming from the pump, going into the tank.
Yeah.
Going from
it's coming from all these different wells out here that were drilled. And yeah, depending on where the water is in the tank, it's going to be turning on either 1 or 2 or 3 or 4 wells to replenish the system.
But the water that actually goes out into the field is coming from the tank.
Correct.
So everything's gone basically from the well to the tank, back through the filtration system, and then out to the field?
Correct. All right, so we're out. This is field B and C to my left. This is B and C. We're utilizing what's called a spot spitter, which that's a pressure compensating emitter that sprays over the top of a pot, versus some irrigation system is more of a drip or a drip system. This is more of a spray, still considered drip irrigation, but sprays nice and evenly over the top of the root ball for even watering, as well as we can irrigate a little bit quicker than we can with just a standard drip.
Are you not concerned that the water is going to spray up into the leaves and cause mold?
This is more of a down spray.
Okay.
So there will be some misting and a little bit. Hopefully we're irrigating early enough in the day to where at the end of the day the leaves aren't saturated or creating an environment that might contribute to powdery mildew or something like that. So, and also with maintenance practices, I know these guys are really cleaning up the inside of the plant, trying to create more airflow.
Okay.
So in combination of irrigating early in the morning, the down spray of the emitter, and cleaning the plant out for good airflow will eliminate most of those issues.
Okay, when is the ideal time to water?
I guess it would depend on who you're asking, but usually I prefer to water in the morning, just right as the sun's coming up, so we could start as early as 5, try to be done by about 10. But really that's up to the grower. I try not to get overly involved with their methods and practices, but yeah, typically earlier in the morning, try to be wrapped up by 10 o'clock at the latest.
Okay, so if you have an acre of cannabis, how long with this system? Okay, so we've got 3.5 acres, so let's just say it's 3.5 acres. How long will it take to water this, all the fields? I
have to look back to figure out that exact number, but it was just under 4 hours.
Okay.
Yeah, and so we've sized everything to where we can be watering multiple fields simultaneously to cut back on that water window. So here, as mentioned, we have the sprayers. The new field A is going to be troughs. So a little bit different style, and then within those troughs we're going to be doing more of a drip style irrigation with a drip tube with the emitters built into it. There'll be three runs per trough, so a little bit different form of irrigation over there.
Okay, and are those drippers just going to drip droplets out, or are they also going to spray a more finer mist?
It's more of a droplet.
Okay.
Yeah. So no spray, and yeah, the emitter spacing on those, we have 1 foot spacing, 0.6 gallons per hour. We'll be running 3 pipes, three drip lines per trough.
Okay. I know that they have multiple wells tied into the system. What is the benefit of having multiple wells as opposed to everything coming out of one well?
Multiple reasons. So one would be redundancy. Second would be volume of water, so having multiple wells to pull from. Another aspect, I couldn't speak for this area, but I know in Colorado, some wells can run dry toward the end of the season. So always having that backup or having that redundancy, as well as water quality. Different wells, even in a similar area, can produce much different water as far as quality, iron content, sulfur, and so forth.
Have you done water tests on this water to see?
We have, yeah. So the initial well that was dug, I did send in for water testing and analysis. The new wells, the tests were sent out. I have not received the results of those yet.
Okay. And then the system's also going to be used for nutrients, is that correct?
That's correct. So here we're standing at what I call the injection station. Also, we refer to this as fertigation, so irrigation in combination with fertilizer. So that's kind of the new term for that, fertigation. But anyway, the water will come in from our pump station we were at earlier. It comes into the building here. It does kind of a U shape as it goes through. None of the equipment is installed yet, but on the back wall, I'm sorry, let me start over. On the left side, we'll have a water meter, and it's an ultrasonic water meter, very, very precise, not like a standard water meter. So that's going to watch the flow very accurately and be able to see fluctuations much closer than a standard water meter. Then on the back wall, we'll have the nutrient injection. So it'll be a series of diaphragm pumps that pull concentrated nutrients from the back side of the building where we have cone bottom tanks. So those are big tanks that they'll be able to put their nutrients in. Usually it's an A and a B or ABC. So we'll have those as well as an acid. This particular system is brand new. It's called NDS-IQ. So it watches everything in real time. You can set up different recipes to hit different parameters, as well as automatic pH correction. So downstream of the injection, we go through a mixer and then into the monitoring loop, where we're going to have a series of redundant sensors and really nice equipment. They're GF sensors to monitor different parameters like EC, electrical conductivity, also pH, and temperature. So we'll be able to monitor all that, and the system can adjust in real time to hit certain parameters of pH. I'm not sure what these guys are using out here, but we're trying to stay right around a pH of 6 is ideal. So as it goes up or down, the system can adjust itself so that we remain pretty steady at that 6 pH.
I am curious about the temperature of the water. If it gets too warm or too cold, can the system adjust for that, or is this just something you're keeping track of to see?
This is something we're going to keep track of, and if we need to make modifications, there's different chillers, or we do heaters in line. Usually not on agricultural or larger drip systems like this. It should maintain. As we're going to be depleting the tank, and it's going to be refilling daily. So it might increase a little bit as far as temperature, but really the temperature, if we can keep it around 70 degrees, is really what most growers shoot for. So not too cold and not too warm, about room temp, depending on what room temp is. So it's been over 100 degrees out here for the past week, and that temperature would not be good for the plants. But also, what I think about, and most of our irrigation is underground, so it's going to remain cool. As well as if you look at the field, all the drip material that we've sourced, all the tubing, everything is white. Unlike the black drip, which gets scorching hot, this is going to maintain a cooler temperature, and hasn't been an issue in the past with other systems. But with the monitoring and with the sensors, we'll be able to make decisions based on that.
That is amazing. I'm absolutely astonished at the complexity of the system and all the thought and the engineering and the mathematics that went into it.
Yeah, well, today's a big day. We're turning the pump on and we're going to start running water, so I'll be able to to check my math, I guess, or we'll see how the system lines up with my math. But I'm fairly confident, very confident that it's going to work the way that we want it to.
I noticed that all the pipes are already covered, so if you end up with a leak somewhere, how do you detect where it is?
It will show itself pretty quick.
Okay, like
Yeah.
are we going to get a geyser coming out of the ground? Or?
Hopefully not, but sometimes it's a kind of a seepy spot that shows up after a day or so. If it's a catastrophic type of a crack or break, it will show itself very quickly. And a lot of the pipe and some of these components are gasketed, so they're not glue fittings. The pipe is inserted into the other pipe with a gasket. It could easily push back out, so we use the weight of the earth to hold everything together. So yeah, and we've never done a system where we've left the pipes exposed. And this goes back to, we used to do a lot of golf course construction, and this is just the way it's the way you do it.
Okay.
Yeah.
So we're looking forward to, what is it, T0 or ground zero, something like that, I don't know.
Yep, getting ready, getting excited to flush out the system. Also, it's a big day, so usually pretty nervous just to see what happens. But I think everything went together very nice out here. I don't anticipate there being some issue, but you never really know until you pressure it up and let it sit for a little while.
And then how long will you let it run to test it to see how everything's going? Or
So we'll start by flushing everything out, zone by zone. We don't want to run anything into the drip. We want to keep the drip clean. We do have a series of filtration, so we even have more filtration here at the injection station. This is a self-cleaning disc filter by Omniad called Mini Sigma, which is really nice. So we've got another filter here, and then we actually have another filter at the zone. We can walk over there in a second. So really flushing everything out, cleaning out our filters, and then we'll start running the drip. So it's a series of flushing everything out, and then for the first couple days we'll pressurize the system during the day.
Okay.
So bring it up to full pressure and let it sit. At night we'll go ahead and turn the pump off in case something happens at night. And so we'll do that for the first 2, 3, 4 days or so until we're confident that everything's holding together tight. Okay. All right, so we're out here, field, this is field B and field C. We have our main line that runs down the middle here, and this is one of our valve assemblies. So pretty beefy valve assembly here. We've got some air relief valves, a maintenance valve, our final filter. This is our last line of defense in case anything's accumulating in the line, and then this is our electric valve, solenoid operated. This is pressure regulated, so I can actually adjust the pressure right here on the valve. We have a pressure gauge, so as we're adjusting the pressure, we can see exactly where it's running, or as the guys are using it in the field, they can monitor it as it's running. Also, we just threw in some boiler drain valves, so we could always plug a hose into this. It'll be live. On this side of the valve, it's going to be live all the time. So you could easily plug in a hose, fill a sprayer, or if there was a clogged dripper, we could water that plant by hand.
Okay. What's the ideal pressure for this system?
We're going to be running right around 30 psi. So the drippers can run anywhere from about 20 to 40, but we'll start at 30 and see how that works.
Okay.